Swayam Prabha. Digital India. Educated India.
Welcome to the sixth module of the lecture series on design of transmission elements. This module is related to rolling element bearings, in which we will first of all study what this rolling element bearing is. Then it will be compared with the previously studied bearing, which was sliding contact bearing. Thereafter, we will study different types of rolling element bearings. Then we will come to the selection methodology of this rolling element bearings. In this particular module, the design is basically the selection module. From the catalog of manufacturers, we select a best suitable rolling element bearing for our application. So, let us start this module, the rolling element bearings. In a rolling element bearings, the contact between the bearing elements is rolling instead of sliding as found in the journal bearing. The sliding contact bearing or the journal bearing, which we studied in our previous module, in that there was a bearing, or you may say it as a bush also, bearing, and the journal or the shaft was something like this. Initially they were having metal to metal contact. There may be in fact a very small layer of lubricant, and due to rotation of this shaft, there was separation between the bearing and this shaft due to development of a pressure. That pressure may be applied externally in the case of hydrostatic bearing. So, there was a lubricant in between the shaft and the bearing. But in contrast to that, in the rolling element bearing, we have a shaft here. This is the shaft, and the bearing is a rolling element bearing, in which you see there is this hedged part, this two hedged parts are there, and accordingly it will have a inner race. This is the called inner race. Then the rolling element is there, and after the rolling element is another part of the bearing, which is called the outer race, which is again shown in hatch. This, the green colored is the inner and outer race. This is the inner race, this is the outer race, and in between inner and outer race are the rolling element or the rolling elements. This may be a ball, this may be a roller, this may be a taper type of roller, or this may be a pin. That we will study in detail in our coming slides. And the load which is acting is in this way. So, in between these two races, there are rolling elements. This, okay, separated by each other, they will not touch each other, and we will see later on this is done by providing a case in this space. Okay, so this red colored is the shaft and the green colored and the hatched area is the inner and outer race. This is the outer race, this is the inner race, in between them is the roller. So the shaft is supported on rollers or balls or pins. So this element may be a roller, balls or pins. The roller may be a tapered roller also. Tapered roller also. So a bearing of this type has very small friction. The reason being that the friction due to rolling of surfaces over each other is considerably less than the sliding friction. So you see, this is your journal bearing or the sliding element bearing. The bearing will look very simple like this, but in the case of rolling elements, we have different components, the inner race, outer race, the ball and the case, like that, and in the disassembled part the roller is visible here. Now the lesser amount of friction which occurs in the case of rolling element bearing is due to conversion of the sliding friction into a rolling friction. In the case of sliding element bearings, that is just analogous to sliding of two elements or the two surfaces or two masses with each other, and this is the area of contact, and a force is applied to slide this mass against this one. So here lot of friction will be there, and that will be the sliding friction. Now if some lubricant is applied between these two surfaces, then the friction will reduce, but there will be considerable amount of friction. But if these two surfaces are separated by the rolling elements, and then when the smaller force may slide this mass against this one, and that is done in the rolling element bearing. The shaft which is shown inside is separated by these rollers, and when the shaft will rotate and certain mass is there, this mass is supported by these balls, and when this shaft will rotate, these balls will also rotate, and thus there will be a rolling friction between these two surfaces. The inner race will rotate with the shaft, and so inner race will also move like this. In some of the applications, inner race is fixed and outer race is moving. So that may be the case also. So for starting conditions and at moderate speeds, the frictional losses in rolling contact bearing are lower than that of equivalent hydrodynamic journal bearing. This is because of sliding contact is replaced by the rolling contact, resulting in a low coefficient of friction. Now if we compare the journal bearing with the roller bearing, then based on different parameters, this comparison chart is made. So based on the speed, the journal bearing operate efficiently in high speed, because with the increase in speed, the hydrodynamic pressure which automatically develops due to wedge action increases. Roller bearing operate efficiently in low speed, because at high speed there will be noise. Friction, on the parameter friction, if these two are compared, then journal bearing power loss due to friction increase at high speeds, which requires proper oil flow rate for heat rejection. For the case of roller bearing, starting friction is low but higher friction in high speed. On the maintenance point of view, Journal bearing needs maintenance, permanent care about lubrication is required. So, continuous supply of lubrication is required for the case of this journal bearing or the sliding contact bearing. For the case of roller bearing, occasional attention is required. So, on maintenance front of view, the rolling element bearings are better. On the parameter shock, as journal bearing is separated by a layer of lubricant, and so damping property is good, and so sliding contact bearing bear the shocks and high loads. But for the case of rolling element bearing, we have seen that the shaft and bearing is connected with the help of metallic rolling element, that may be ball, that may be roller, and so the rigidity is there, and whatever deformation will be, that will be elastic deformation. So, the roller bearing does not withstand the shocks and high loads. Axial load, very long to bear the shocks and high loads. In the case of roller bearing, relatively less length is required. Now, bearing life, as there are no any contact between shaft and the bearing for the case of sliding contact bearing, the longer life can be achieved if continuous supply of lubricant is maintained. For the case of rolling element bearing, comparatively short life is there. Failure, lower possibility of failure if continuous supply of lubricant is there. There is higher possibility to failure in the case of rolling element bearings. Application point of view, the rolling element bearings are used in higher speed applications like turbines and compressors, etc. For the case of rolling element bearing, they are used in lower speed applications like gearboxes. This figure shows you, and this figure is taken from SKF catalog. This figure shows you the load the rolling element bearing may bear. On a shaft, there may be a radial load, there may be axial load. We have seen in the case of gear drive, when the drive is through spur gear, then there is only radial force and transmitted force, and these two force becomes a resultant force, and that will be a resultant radial force. So, in the case of spur gear, there will be only radial force. So, this force will be there, and so you have to choose bearing accordingly. You may choose rolling element bearing or the roller bearing depending on the amount of load which is acting on the shaft. But we have seen that for the case of helical gear, for the case of bevel gear and worm and worm gear, there will be radial force and axial force. Okay. Now, in this figure it is clear that this shaft is supported by two bearings. Among them, the first one is the radial bearing accommodating radial and axial load, and radial bearing accommodating radial loads only. This is accommodating only radial load, but this is accommodating both radial load and the axial load. Now, this is a bearing which is used to support only the axial load. You see the difference in the design. In this case, the load is acting in this direction along the axial direction, and the two surfaces, the inner race and the outer race, are along the load, and so and here you have a rolling element bearing. So, this is to support pure axial load. Now, the thrust bearing for combined loads, if the roller is a tapered roller, then this may support both axial load, this is the axial load, and this one is the radial load. because it is directing towards the center of rotation of the shaft. This is the shaft. Now, this is a particular case where the load is acting along this way. Okay, in this way the load is acting. Angular contact bearing, where the contact is along the angle. You see here the contact is at this point of the ball and the races, but in this case the contact is at this location, at an angle of this shown by the red color line, and the angle of contact is given by this alpha. Now, nomenclature of a ball bearing. The different components of a ball bearing are shown in this figure. We will have an inner race, this is shown here, then outer race, okay, this is the outer race. The width of the bearing will be given by this one. This is the width of the bearing. Then corner radiuses are there. The races have some corner fillet like this. So, this is the corner radius, and these are the shoulders. Then the ball, to separate the ball, we will have separator or retainer, or you may say case also. The ball is inside a case or separator. You see, this is the separator shown here, like that, and the separator is shown here. So, the ball will be inside this separator, and so they will not mingle with each other. Now, this is the face of the bearing. Now, the outer diameter is the outside diameter of the outer ring or the outer race, this one, this to this. Okay. So, the basic components are first the inner race, then the outer race, then the balls or the rolling elements, you may say. And in the case of ball bearing, it will be ball. For the case of rolling element bearing or the roller bearing, there will be rollers, balls and the rollers, and like that. So, you may say the rolling element will be inside the case, and this is the separator, and the inner diameter of the inner race is called the bore. Bore of the bearing is decided by the diameter of the shaft, because shaft will fix inside the inner race. Now, a rolling contact bearing consists of 4 parts: inner and outer races. In a disassembled form, they are shown here. This is the inner race, is the outer race. In the inner race, you may see the circular slot is there, this circular slot, to give space for the balls. Well, you may see like this, this curve will be in the inner race like this, and your ball will be resting here. Okay. And there will be a point contact and line contact depending on the type of rolling element bearing. So, this is the inner race, inner ring, is the outer ring, and in the outer ring also inside there is a curved slot. curved ring. In the inner race, inside this curved ring will be there throughout the circumference. Inner ring, on the outside surface there will be circular slot all along the circumference. Then to avoid entering foreign materials inside the where the balls are, some seals are also used. So in this bearing there are two seals. One seal is provided here and another seal is provided on the back side here, and this will seal the your inner race, outer race and the balls or the rolling elements, and so it prevents coming in the foreign materials in the space where relative motion is there, and that will prevent the wear. Then rolling elements and a case. These are the parts. A case which holds the rolling elements together and spaces them evenly around the periphery of the shaft. Now, depending upon the type of rolling element, the bearings are classified as ball bearing, which is shown here. The balls are used. Balls means spheres are used. Then cylindrical roller bearing. You may say in place of a spherical ball, now we have a cylinder. Cylinder, it means it will have a certain diameter and certain length like this. So what will be the difference between this cylindrical roller bearing and the ball bearing? And that is the point of contact between the ball or the rolling element and the cases. In this case, in the case of ball bearing, there will be point contact, and in the case of roller bearing, there will be a line contact like that. And in this case, there will be point contact. Taper roller bearing. You see, this in the case of cylindrical roller bearing, they are straight, but in the case of taper roller bearing, the rollers are something like this, tapered. So it can support both axial and radial load. Then needle bearing. Needle bearing is the difference between the cylindrical roller bearing and the needle bearing. Here the diameter of the cylinder is smaller in comparison to the length, and here the diameter is appreciable in comparison to the length. So in the needles, they will look like this in comparison to this cylinder, this. Now depending upon the direction of load, the bearings are classified as radial bearing and thrust bearing. When the load is only in the direction of radial, then it is called the radial bearing. When the load is only in the direction of axis of rotation, then it is the thrust bearing. Certain types of radial bearings can also take thrust load. There are certain type of radial bearings which can take some amount of thrust load also, while some thrust bearings are capable of taking radial loads. So in this case, you see the tapered roller bearing, it may take both the axial load and the radial load. Here also we have a ball bearing which can take both the radial load and the axial load. There are the different types of ball bearing: the deep groove, finishing notch, angular contact where the contact is along angle, then the shielded, sealed, then external self-aligned, double row where the two rows of balls are there all along the circumference, then the self-aligning type where the misalignment of shaft is possible, then we go for the self-aligning, then the thrust bearing and the self-aligning thrust bearing. Here these are shown and some details is given, like a ball bearing which is called the deep groove ball bearing. This is particularly versatile bearings suitable for high and very high speeds, accommodating both radial and axial loads in both directions, robust, low maintenance and available in many designs. Then angular contact ball bearing, bearings with good running properties and high axial load carrying capacity, designed to accommodate simultaneously acting radial and axial load. And self-aligning ball bearings, insensitive to static and dynamic misalignment. If there are some misalignment, then it takes care of that. These two-row ball bearings generate very little frictional heat even at high speeds, leading to minimal maintenance requirement. Now let us see in detail the deep groove ball bearing. The most frequently used bearing is the deep groove ball bearing. It is found in almost all kinds of products in general mechanical engineering. In this type of bearing, the radius of ball, you see here the ball is shown, and the radius of the ball is slightly less than the radius of curvature of the grooves in the races. So this is the groove in the races. Now radius of curvature of the groove in races is large in comparison to the radius of the ball, and so what happens is there will be a point contact and this groove is deeper, and so it can support both the thrust load and the radial load. Kinematically, this gives a point contact between the ball and races. Therefore, the balls and the races may roll freely without any sliding. The advantages of this deep groove ball bearing is, due to relatively large size of balls, deep groove ball bearings has high load carrying capacity. Deep groove ball bearing takes loads in the radial as well as axial direction. Due to point contact between the balls and races, frictional loss and the resultant temperature rise is less in this bearing. The maximum permissible speed of the shaft depends upon the temperature rise of the bearing. Therefore, deep groove ball bearing gives excellent performance, especially in high speed applications. Deep groove ball bearing generates less noise due to point contact. Now deep groove ball bearings are available with bore diameters from a few millimeters to 400 millimeters. So they can be used for very small diameter shaft to the shaft diameter up to 400 millimeters. Now the cylindrical roller bearing, when maximum load carrying capacity is required in a given space, the point contact in ball bearing is replaced by line contact of the roller bearing. In this figure, a ball bearing with the races, groove of the races is shown. This is the ball and there is a point contact, and here the races with the roller is shown, and due to this roller contact with the races, there will be a line contact shown by this red color line. So the point contact is converting into a line contact, and so this bearing can take more load in comparison to this bearing. Well, so a cylindrical roller bearing consists of relatively short rollers that are positioned and guided by cage. Advantages of roller bearing is, due to line contact between rollers and races, the radial load carrying capacity of cylindrical roller bearing is very high. Cylindrical roller bearing is more rigid than ball bearing. The coefficient of friction is low and frictional loss is less in high speed applications. There are some disadvantages also, like in general, cylindrical roller bearings cannot take thrust load because of their shape, and they rest on the surface like this. So they can take only the radial load. Cylindrical roller bearing is not self-aligning. It cannot tolerate misalignment. It needs precise alignment between axes of the shaft and the bore of the housing. Cylindrical roller bearing generates more noise because of more contact. Now the angular contact bearing. In angular contact bearing, the grooves in inner and outer race, you see, the groove which is made in the outer race, this is the groove. This is the groove in the inner race. You see the difference in the groove. In the simple ball bearing, the grooves are something like this. The ball is here and the groove of outer race is something like this. So point contact is perpendicular to the axis of rotation. Contact between races and ball is along the line perpendicular to axis of the shaft. But in this case, the grooves are made in such a way that contact is along this dashed line. Okay, so in angular contact bearing, the grooves in inner and outer races are so shaped that the line of reaction at the contact between balls and races makes an angle with the axis. Okay, this is making an angle with the axis. This reaction has two components. So this contact reaction has two components, one along the radial direction and another along the axial direction. Therefore, angular contact bearing can take radial and thrust loads both. Angular contact bearings are often used in pairs, either side by side or at the opposite ends of the shaft, in order to take the thrust load in both directions. Advantages: angular contact bearing can take both radial and thrust loads. In angular contact bearing, one side of the groove in outer race is cut away to permit the insertion of large number of balls than that of deep groove ball bearing. This permits the bearing to carry relatively large axial and radial loads. Therefore, the load carrying capacity of angular contact bearing is more than that of deep groove ball bearing. The next bearing is the self-aligning bearing. The self-aligning bearing consists of two rows of balls. You see, there are two rows of balls in place of one row which we had studied till now. This is the bearing. This is the bearing of NSK bearings. In this case, the assembly of the shaft, the inner race and the balls with case can freely roll and adjust itself to the angular misalignment of the shaft. That means here you see the outer race is having this type of groove and the inner race has two separate grooves for the two rows of the balls. So what happens is, this assembly, the inner race and these balls may rotate with respect to an axis perpendicular to the screen. So with the misalignment of the shaft, this assembly, you may see this ball, this ball, this ball, and the inner race. This inner race, and this one, you can delete this one. Okay. So the thing which is shown by red color and this ball and this ball, the all elements shown in red color may rotate with the misalignment of the shaft. Suppose the shaft has misaligned like this, so the assembly will rotate in this direction. The assembly shown in red color will rotate in this way, and you may see here also. Permissible dynamic misalignment is approximately 0.07 to 0.12 radian, 4 to 7 degrees under normal loads. You may see in this figure how the assembly, which is shown by red color in the previous slide, is rotating with the misalignment of the shaft. This is the original axis of the shaft, and with the misalignment of alpha, this complete assembly, the balls and the inner race and the shaft, is rotating with respect to this surface. You see here also. In the case of rollers, here the ball is there, there may be a roller also. Okay. And this type of misalignment of shaft is there, that can be accommodated by this self-aligned bearing. So A figure is showing the shaft aligned with bearing, shaft is aligned with the bearing, and B is showing the shaft misaligned with the bearing. There are misalignment, this is the angle of misalignment, and this is showing the self-aligned bearing. See this assembly. This one is rotating on this, and the same principle is used in this case, in these two cases. Now others bearings are the spherical roller, 2 row, then the tapered roller, this is the tapered roller, that can take both the axial and radial load. This is shown here also, the tapered one. This is the thrust bearing, and here the thrust bearing is shown. The two races are there, this upper race and bottom race, the case and the ball. There may be ball, there may be roller. Now types of roller bearings: the straight cylindrical, spherical roller thrust, tapered roller thrust, then the needle, you see the relative dimension of the length and the diameter, then the tapered roller, then the self angle, steep angle tapered roller. So roller bearings serve the same purpose as ball bearings, but can carry much higher loads and support large shaft diameters because of their line contact instead of point contact. The rollers of the cylindrical roller bearing in this case have length to diameter ratio of 1:1 to 3:1. Now the axes of the rollers are parallel to the rotational axis of the supported shaft. The bearing usually is a cylindrical roller bearing. Now the relative load carrying capacity of different types of bearings are given in this table. In the single row deep groove ball bearing, the radial capacity is if Fr, then the thrust capacity should be 0.7 of the FR. Well, in a two direction it may work, along the axial direction and along the radial direction. But along the radial direction, it can take a smaller load in comparison to the radial directional load. In the filling notch, these are the values. In comparison to the single row deep groove ball bearing, the FR is the radial load that the deep groove ball bearing can take. So, in the filling notch, it will be 1.2 to 1.4 times this FR. In the case of angular contact, it will be 1 to 1.15 of this FR of the single row deep groove ball bearing, and the thrust load which this angular contact bearing can take is 1.5 to 2.3 of the FR. So, depending on what amount of radial load FR and what amount of axial load FA will act on your shaft, you will choose a type of bearing. Well, now if the thrust load is smaller in comparison to the radial load, you may go for the deep groove ball bearing. But if thrust loads are more, like 1.5 to 2.3 times the FR, 1.5 times the FR, 0.2 type of the FR and 0.7 of the FR. So, in the self-aligning bearing, the self-alignment factor is there. So, if there is a misalignment possibility, then you will go for this, otherwise no. Now, in a single row deep groove ball bearing, if FR is the radial load that can be taken care of, now if you will take the two balls all along the circumference, then the load carrying capacity will increase, and now it can take 1.5 times the radial load that a single row deep groove ball bearing has taken, and the thrust capacity will be 1.5 of the FR, okay, two dimensional or one dimensional. Now, the terminologies which are used in the case of rolling element bearing. So, some frequently used bearing terms are explained here. The most common symbols are D, small d is used for the bore diameter. So, if you have a bearing like this, then the inner diameter of the inner race will be the bore, and it will be given by small d. Capital D will be for the outside diameter of the outer race, and that will be the outside diameter of the bearing also. Then B is the width of the bearing. This is the width of the bearing. And for the case of thrust bearing, this height of the bearing is H, and R is the chamfer, okay, R is the chamfer, and alpha is the contact angle in the case of your angular contact bearing. This alpha will come into picture. Now, if deep groove ball bearing is there, or the rolling element or the roller bearing is there, then this alpha will not be there, because in that case the contact between races and ball will be perpendicular to the direction of the axis. Now, this figure shows you how the balls and rollers are assembled inside the space of inner race and the outer race. First of all, inner race is made to rest at the bottom of the outer race. Then there will be more space at the top. So, there in this space your balls will be filled, and then this race is moved up, this is moved up, and these balls are separated, and then a cage is mounted from top and bottom, so that the balls may not touch each other and intermingle with each other, and they may be at equidistance from each other. That is shown in the fourth figure. This is showing the contact between the your races and the ball or the roller. This may be point contact and the line contact, depending on whether it is a ball or the roller. Now, standard dimensions according to Anti-Friction Bearing Manufacturers Association, a bearing is denoted by two digits. The first digit represents the width series, which is the ratio of width to bearing section height. 8 standard width series are there. They are 8, 0, 1, 2, 3, 4, 5 and 6, where the successive numbers indicate the increasing value of this ratio of the width to the bearing section height. The second digit represents the diameter series. It denotes the outside diameter of the bearing. 7 standard diameter series are there, and they are 7, 8, 9, 0, 1, 2, 3 and 4, where 7 represents the outside diameter, the smallest outside diameter. Now, if you see this figure, then you may see the different shape of the bearing depending on the width series and the diameter series. Okay. Along this, the width series is given like 0, 1, 2, 3, and along this the diameter series is given, and bore is this one. Okay, it will go like, and this is the axis of the shaft or the bearing, you may say both way, axis of the. Okay, so if you have dimension series given by 0, 0, first digit is 0, it means the width series is 0 and the diameter series is 0. Then the shape of your bearing will be something like this. Diameter series gives the outside diameter, so the outside diameter is smaller. The width series is 0, so the width of the bearing, this width you see, is smaller. The width series suppose is constant, it is 0, but the diameter series is increasing from 1 to 4. The series is now 2, then the bearing will be designated as 0 and 2. Width series remains 0. So, this will be the shape of the upper half of the bearing. The bottom half will be just. Now, if width series again is 0, but the diameter series has become 3, then the outside diameter will increase, and that is represented by this shape. Diameter series has increased to 4. So, with that. Now, here we have a width series 1. Okay. Diameter series 0. So, the outside diameter will remain same as for the case of this one. So, outside diameter will remain same, but the width has increased because width series is now and this one. Zero zero and 2 1, but the diameter series is same. So the width is more, but the outside diameter is same. Similar case, compare these two. The and 0 2. Outside diameter is same because diameter series is here width is smaller, but here width is more. The same thing is illustrated for other width series and the diameter. 2 2, where diameter is again same, this 2, but width is now 2 series. So blue colored bearings with dimension given by this one is 1 2 and this one is 2 2. With the change in width, meter is same. Now the same thing you can see for fixing the width series but changing the diameter. These are the cases where the width series is fixed but the diameter series is changing. So the outer diameter in this figure again, the different shapes of the bearings are given with the change in width series and the diameter series. Shown here. On the same shaft, you can have many type of bearings and others. This is the shaft, single shaft on an and the diameter series which you have used. A particular bearing is shown here. This is the outer race and you have a ball. Well, and the shape. Now to illustrate the Anti-Friction Bearing Manufacturers Association procedure designated as 20 BC03. The number 20, this 20 represents the 20 mm bore. 20 mm and 03 represents the width series and the diameter series. Width series is 0, width series is 0 and the diameter series is 3. So see where it is this this. Is again the comparison of the Anti-Friction Bearing Manufacturers Association way of designation and the designation bearing. This is misnomer anti-friction. There will be some friction, but this rolling element bearings are sometimes called anti-friction bearing because the friction is lesser in comparison to the sliding contact. But is SKF, and this figure represents the SKF way of designating the bearing. It is something different. Association's way of designation, but the basic concept is same, okay, and that we will see in this. The last two digits represent the code for the bore. So is given, or whatever way the bearing is designated, the last two digits, this last code for the bore. The digits 00, 01, 02 and 03 represent 10 respectively. The digits starting from 04 represent, that means if 00 is there, then the bore is 10 mm and the bore will be 12 mm. If 02 is written here, then the bore will be 15 mm. If 0 beyond this 03, if any number is given, then the bore will be that number is written as the last two digit, then 4 multiplied by 5 means, okay, the SKF bearing catalog has denoted 0203 series as, that means if the width series is 0, diameter series is 2, then in the SKF, okay, now if 03 is written in an anti-friction bearing manufacturer, writes it as 63, and 6 is for deep groove ball bearing. To illustrate the SKF procedure, suppose a bearing is designated as SKF 6304. So last two digit is 04, therefore the bore will be 04 multiplied by 5 is equal to 20 mm. And 6 means it is the deep groove ball bearing. The first digit is 0 and the second is 3. So it is 03 type as per Anti-Friction Bearing Manufacturers Association. So 0 is the width series and 3 is the diameter series. Okay. In this slide, different types of bearings are shown and their designation methodology is there. Like this is the deep groove ball bearing and it is designated by 6. Okay. So if the first letter in the SKF bearing is 6, it means it is a deep groove ball bearing. If it is 0, then it is 2-row ball bearing. If it is 2, then it is tapered bearing. Accordingly, the different numbers are there, or alphabets and numbers are there. Well, so last two digit gives the size, that means the bore size. Well, and this designates the bearing series dimensions. The diameter series are here 7, 8, 9, 0, 1, 2, 3, 4. and similarly there will be a width series. Okay. Now the selection of bearing type. The type of bearing in a particular application depends upon the requirement of the application and the characteristics of different types of bearings. For low and medium radial loads, ball bearing is used. For heavy loads and large shaft diameter, roller bearings are selected. Deep groove ball bearing, angular contact bearing and spherical roller bearings. In the applications where the load acting on the bearing consists of two components, radial and thrust. Self-aligning bearings and spherical roller bearings are used in applications where a misalignment between the axes of the shaft and housing is likely to exist. So with this we are stopping at this stage in the lecture 1. In this lecture 1 particularly we studied about the rolling element bearings and the different types of rolling element bearings, their advantages, disadvantages and applications. And thereafter we studied how to designate a rolling element bearing as per Anti-Friction Bearing Manufacturers Association and as per one of the manufacturer, which is SKF. In the catalog of manufacturers, they give the bearing designation methodology adopted by their company. So if anyone is desirous to know different designation methodology, they may refer the manufacturer's catalog. Thank you.